Hello friends and welcome to YouTube channel on Engineering Mathematics by Dr. Navneet. Friends, in this video lecture we are learning the fifth method for finding the inverse Laplace transformation, which is called as inverse Laplace transformation by differentiation of phi of s. So let's first discuss the theory part related to this method. Friends, we know that according to the effect of multiplication by t property of Laplace transformation of t raised to n into f of t is equal to minus 1 raised to n into nth derivative with respect to s of phi of s, where Laplace transformation of f of t is equal to phi of s. So this property is known to us. So friends, in this property in particular, if we put the value of n is equal to 1, then we get this as Laplace transformation of t into f of t is equal to, this is minus 1 raised to 1 into first derivative of this phi of s with respect to s. So we can write this as phi of s. Moreover, we can write this as t into f of t is equal to, so if we apply the inverse Laplace transformation on both sides, so that we get this as inverse Laplace transformation of, this is minus, so we can adjust minus to left side, then this is derivative of phi of s with respect to s, so we can write directly this as phi dash of s. Now here if we take this minus 1 upon minus t to the right side, then we get this as f of t is equal to, this is 1 upon t with minus sign into inverse Laplace transformation of phi dash of s. So this is the result. So this f of t. So from this equation we know that Laplace transformation of f of t is equal to phi of s. So we can directly write this as f of t is equal to inverse Laplace transformation of phi of s. So that if we put the value of f of t is equal to this term, then we get final result as inverse Laplace transformation of phi of s is equal to minus 1 upon t into inverse Laplace transformation of, this is phi dash of s. So now friends, this result is useful to solve the examples based on the inverse Laplace transformation by differentiation. So this formula. So now to apply this formula means what? So denote the given example by the term phi of s. Now to find out its inverse Laplace transformation means minus 1 upon t into inverse Laplace transformation of phi of t. So simple thing once again. So to find out the inverse Laplace transformation by differentiation of phi of s, denote given example by phi of s, find out its derivative, apply this formula, we will reach to the answer. Now friends, here question arises that when we have to apply this method number 5 for finding the inverse Laplace transformation. So for this we have to take note that, so this method number 5 for finding inverse Laplace transformation is applicable only when given example is in terms of log. So given example may be in terms of tan inverse, so given example may be in terms of hyperbolic tan inverse, so or given example may be in terms of cot inverse term. So whenever such type of term is available, and to find out the inverse Laplace transformation of such type of function, we are using the concept that is called as inverse Laplace transformation by differentiation of phi of s. So this is the theory part related to it. Now let's take the first example. So first example is that, so find inverse Laplace transform of log of, suppose this is s plus a upon s plus b. So now this is the simple example. Let's take this as the example. Now friends, here log term is available and question is to find out the inverse Laplace transformation. Whenever log tan inverse, hyperbolic tan inverse, then cot term is available, then use differentiation of phi of s concept for finding the inverse Laplace transformation. So then formula for this concept is, so by results, so we get this as inverse Laplace transformation of phi of s is equal to minus 1 upon t into inverse Laplace transformation of phi dash of s. Now our question is to find out the value of phi dash of s. So for this, so let's denote the given example by phi of s. Let's denote the given example by phi of s. So let phi of s is equal to log of s plus a upon s plus b. So now our aim is to use this formula. Let's call this as equation number 1. So to use this formula means what? So we can easily take its inverse Laplace transformation. Only find the value of phi dash of s. Now to find the value of phi dash of s, first simplify this log term. If we try to simplify this log term, then we get this as log of s plus a minus this is log of s plus b. So according to the theorem, log of a upon b is equal to log of a minus log of b. So this result is applicable since log of a upon b is equal to log a minus log b. So this is the equation. Now our aim is to find the value of phi dash of s to get this equation. So phi dash of s, so which is equal to, so derivative of log x is 1 upon x, so this is same. So derivative of log of s plus a is 1 upon s plus a minus this is 1 upon s plus b. Derivative of s plus b is 1, so that's why numerator value is 1 in both the cases. So this is the value of phi of s. Now put this value in the given equation, so we get this as inverse Laplace transformation of phi of s. So what is the value of phi of s? So phi of s means this is log of s plus a upon s plus b. So then its inverse Laplace transformation is equal to, so this is minus 1 upon t as it is, then so this is inverse Laplace transformation of, just put the value of phi dash of s, which is 1 upon s plus a minus 1 upon s plus b. So friends, directly we get this as 1 upon t as it is. So then this inverse Laplace transformation is e raised to minus at minus e raised to minus bt. So in this way we can easily get the answer for finding the inverse Laplace transformation. Once again I will repeat, whenever log, tan inverse, hyperbolic tan function or cot term is exist, then apply this concept for finding the inverse Laplace transformation. So friends, this is the first example. Now let's take the second example. So example number 2. So find inverse Laplace transformation of log of s square plus a square upon s square plus b square. So we can write this as b square. So now according to the result, again we know that, so this equation is of the form, so here equation form is given, so standard form is given. So by result, inverse Laplace transformation of phi of s is equal to minus 1 upon t inverse Laplace transformation of phi of s. So we are using this concept, that means we are using the concept of differentiation of phi of s for finding the inverse Laplace transformation, because log term is available and our interest is to find out the inverse Laplace transformation. So let's denote the given example by phi of s, which is log of s square plus a square upon this is s square plus b square. So let's denote this by log term. So now our aim is to find out the phi dash of s, so that we can write this as log of s square plus a square minus this is log of s square plus b square. Now we can easily find out the derivative of phi dash of s. So we can write this as phi dash of s is equal to, so derivative of log x is 1 upon x, so we can write this as 1 upon s square plus a square. But friends, this is other than s, so derivative of s square plus a square with respect to s is 2s, so we can write numerator value as 2s minus again derivative of log of s square plus b square is 1 upon s square plus b square, but this is other than s, so derivative of s square plus b square with respect to s is 2s. So this is the value of phi dash of x. Now put these two value in equation 1. So after putting this value in equation 1, we get this as inverse Laplace transformation of phi of s. So value of phi of s is, this is log of s square plus a square divided by s square plus b square, which is equal to minus 1 upon t. So this value is minus 1 upon t into, this is inverse Laplace transformation of phi of s. So this is the value of phi of s, which is 2s upon s square plus a square minus, so we can write this as inverse Laplace transformation. We will write here curly bracket. So after linearity property, we get this step directly. So we get this as inverse Laplace transformation of 2s upon s square plus b square. So now friends, this is the step. Now we can easily get the Laplace transformation of this function. This is in our standard form. So we can write answer to this question as minus 1 upon t, then in curly bracket we get this as inverse Laplace transformation. 2 is constant, so we can write this inverse Laplace transformation as cos of at. Again from this equation, minus 2 is constant. Inverse Laplace transformation of s upon s square plus b square, this is in our standard form, cos of bt. Now friends, after taking 2 common, we will get the final answer to this question. So in this way, we can easily solve the example based on the inverse Laplace transformation by differentiation of phi of t. So once again, repetition. So this concept is applicable to find out the inverse Laplace transformation of log tan inverse hyperbolic tan and cot function. Now this is the second example. Now let's take the third example. Now friends, third example is, so find the inverse Laplace transformation of, example is log of, suppose this is s square plus a square upon s plus b its square. So again here a log term is present. So because of this log term, we can apply this concept for finding the inverse Laplace transformation. So let's call this as equation number 1. So then for this equation, find the value of phi dash of x. So for this, let's given example is denoted by phi of s. So value of phi of s is log of s square plus a square upon s plus b its square. Now our aim is to find out the value of phi dash of s. So to get the phi dash of s, first simplify this. We can write this as log of s square plus a square minus, this is log of s plus b its square. Now here square term is there, so which will create problem for finding the derivative. So we are interested to find the value of phi dash of x. So this will create problem for derivative, or which will create complications for finding the derivative. So now again, if we apply the log rule, then we can write this as log of s square plus a square as it is, minus this is 2 times log of s plus b. Since we apply the concept log of a raised to n is equal to n times log of a concept. So this concept we apply here. So now this equation is in our standard form, phi of s. Let's find out its derivative. So phi dash of s is equal to, so derivative of log of s is 1 upon s square plus a square, but this is other than s, so derivative of s square plus a square is 2s minus this 2 is as it is, then derivative of this function is 1 upon s plus b, then derivative of s plus b with respect to s is 1. So this is the simple value of phi of s. Now apply this result. So therefore we write this as inverse Laplace transformation of phi of s. So we directly put the value of phi of s. So value of phi of s is log of s square plus a square upon s plus b its square is equal to. Now just put the value. So we can write this as minus 1 upon t according to this formula, then inverse Laplace transformation of this function. So now again, according to the linearity property, so we may directly write this as, so this 2 and this 2 is constant. We take this 2 as constant outside the inverse Laplace transformation. Then this is inverse Laplace transformation of s upon s square plus a square we will write here one bracket. Then again this is minus inverse Laplace transformation of 1 upon s plus b. Now this bracket will get over. So this is very simple. So we get this as minus 2 upon t. So we take these two directly common from the inverse Laplace transformation according to the linearity property. So now this is the standard result of cos of at, and this is the standard result of e raised to minus bt. So friends, this is the third example. Now let's take the fourth one. Now friends, fourth example. So fourth example is find inverse Laplace transform of, suppose, log of root of s minus 1 upon s plus 1. So this is the example. So now here we are applying the concept of differentiation of phi of s for finding inverse Laplace transformation because of the log term. So let's apply this result number 1. So this result number 1 is available. So now to apply this result number 1, find the value of phi dash of s. So for finding the value of phi dash of s, let's denote the given example by phi of s. So phi of s is equal to, this is log of root of s minus 1 upon s plus 1. So according to the log property, we can write this as log of root of s minus 1 minus, we can write this as log of root of s plus 1. So then we know that root means 1/2. Moreover, we can write this as log of s minus 1 raised to 1/2 minus log of s plus 1 raised to 1/2. Then according to the log property, we can write this as log of a raised to n is equal to n into log of a. So by this property, we write this as 1 upon 2 log of s minus 1, again minus 1 upon 2, this is log of s plus 1. Or we may directly take 1/2 common. We write this as 1 upon 2 log of s minus 1 minus log of s plus 1. So this is the value of phi of s. Now to apply this result, find the value of phi dash of s. So now take its derivative. So phi dash of s is equal to 1 upon 2 as it is. So derivative of this function is 1 upon s minus 1 minus, this is 1 upon s plus 1, which is straightforward. So now to apply this result, so by equation 1, we can write this as inverse Laplace transformation of phi of s. So value of phi of s is log of root of s minus 1 upon s plus 1, which is equal to minus 1 upon t as it is. So this value minus 1 upon t into, so this is inverse Laplace transformation of, so take the inverse Laplace transformation of this function. So here 1 upon 2 is common, so we may directly take this as 1 upon 2, then inverse Laplace transformation of first term, which is 1 upon s minus 1 minus inverse Laplace transformation of 1 upon s plus 1. So by linearity property for the inverse Laplace transformation, so we can write this as minus 1 upon 2t, then its inverse Laplace transformation of e raised to t, then this is minus e raised to minus t. So this is the final answer to the fourth question. So now here for learning the concept of differentiation by phi of s by inverse Laplace transformation, we solve the example based on log term. Now take the example based on tan inverse term. So now which is our fifth example. Now friends, take the fifth example. So now here we are taking the fifth example based on tan inverse. So question is find inverse Laplace transform of, suppose this is tan inverse, so this is tan inverse, so take the value of s plus a upon b. So take the value of s plus a upon b. So again here, whenever log tan inverse or cot inverse term is there, so use the concept Laplace transformation by differentiation of phi of s. So this result number 1 is applicable. So let's denote the given example by phi of s, which is tan inverse s plus a upon b. So now to apply this result, find the value of phi dash of s. That means take the derivative of this function. So phi dash of x is equal to, this is 1 upon 1 plus, this is s plus a upon b, its square. Because we know that, so if we find the value of tan inverse x, its derivative, then derivative of this tan inverse x is 1 upon 1 plus x square. So according to this theorem, we write this theorem directly here, formula. Then, but this is other than s. So take the derivative of this term with respect to s. So derivative of s plus a upon b. So we can write this as s upon b plus a upon b. So derivative of in this term 1 upon b is constant. So derivative of s with respect to s is 1 plus derivative of a upon b, which is constant, is 0. So we can write this as 1 upon b. Now friends, if we try to simplify this, then we get this as this is b square plus this is s plus a, its square. No, we solve here denominator directly. So we get this as 1 upon, this is b square plus s plus a, its square, divided by b square. So we can take this b square in the numerator into 1 upon b. So one b term will get cancelled and we will reach to the final answer b upon. So in our inverse transformation by Laplace transformation, s term is the first, so that's why we can write this as the first term, s plus a, its square, plus b square. Now this is the value of phi dash of s. Now friends, apply result number 1. So if we apply this result number 1, then we get this as inverse Laplace transformation of phi of s. So value of phi of s is tan inverse s plus a upon b. So this is the value of phi of s, which is equal to minus 1 upon t into inverse Laplace transformation of phi dash of s. So this is the value of phi dash of x, which is b upon s plus a, its square, plus b square. Now friends, observe that here constant a is added to the parameter s. So we use here the concept of second shifting theorem for inverse Laplace transformation. So for more detail about the second shifting theorem for inverse Laplace transformation, so please watch our previous video. Now if we apply the second shifting theorem for inverse Laplace transformation, then we get this as minus 1 upon t e raised to minus at into inverse Laplace transformation of b upon s square plus b square. Now this is because of the shifting theorem, second shifting theorem. So now we can write this as minus 1 upon t e raised to minus at, and this is the standard formula of sine of, so this b we take outside the inverse Laplace transformation, then remaining term is 1 upon s square plus b square, which is sine of bt into 1 upon b. So this b term will get cancelled and we will reach to the final answer. So friends, here we solve 5 examples based on the inverse Laplace transformation by differentiation of phi of s. Now time is to provide exercise to you. So now let's take some example for your practice purpose. Now friends, for testing your knowledge, so total 5 examples are provided. So please solve this example. So first example is log of root of s square plus 1 upon s into s plus 1. So answer is given here. Now second example is tan inverse 2 by s. So again answer is given. So cot inverse. So this is same as that of the tan term. So only take the derivative of cot inverse term. So then log of s square plus a square upon root of s plus b. Answer is given. And last example is tan inverse 2 upon s square. So friends, these are the 5 examples which are related to method number 5. Solve this example independently and test your knowledge. So friends, I hope you people like this lecture. So thanks to one and all. Thank you.